Okay, welcome back. In this next video, I'm going to present the even numbered problems in Unit 38. The focus of this unit is power, and the power formula, P equals E times I. So you simply multiply the voltage by the current in order to obtain the power in watts. And so that's the main focus of the chapter, but there will also be Ohm's law included throughout here as well. So let's just go ahead and begin with problem 2. It says a 500 watt electric iron is connected to 120 volts. How many amperes of current to the nearest hundredth does the iron take? So we are given the power. Okay, so the power in watts is 500. And we are also given the voltage, and it is 120. And we are asked to find the current. Okay, so the current formula will be power divided by voltage. Okay, so remember the power is found using multiplication, but the current and the voltage will be found by using division. Okay, so we're going to take 500 and divide it by 120. Okay, and this is going to give us the following answer. And because we were asked to round this to the nearest hundredth, that means rounding to 2 decimal places. So it will be 4.17. Just like that. Okay, the next problem. A 1 horsepower motor uses 900 watts when connected to a circuit. The motor receives a current of 3.4 amperes. Find the voltage to the nearest tenth. Okay, so we are given power. We're also given current this time. And what are we asked to find? The voltage. Okay, so the voltage is found using division. The power is always going to be the numerator when we are dividing to find current or voltage. Okay, so in this case, we take the 900 watts and we divide it by 3.4 amps and we'll get our voltage. So hopefully you can still see that on your video there. So this would be the voltage. This time it said to round to the 10th, which is just rounding to 1 decimal place. So we will write 264.7 volts as our answer. All right, let's look at number 6. How many watts will a motor use if the voltage is 240 and the motor is drawing 40 amperes of current? So this is the third possibility for this formula. We're given the voltage and we're given the current. We are asked to find the number of watts. In other words, find the power. So this is when you multiply. So we have to do E multiplied by I. So 240 is multiplied by 40. Okay, to get 9,600 watts. If you prefer, this is the same as 9.6 kilowatts. So you can instead write 9.6 kilowatts if you like that better. Okay, so that's the answer for problem 6. Number 8. A circuit has a voltage of 120 volts and a current of 7.5 amps. Find the amount of power used. So this problem 8 is exactly like problem 6. Okay, because we are given E and I. We're given E and I, and we are finding P. So we simply multiply. So the value for E is 120 volts, and we need to multiply that by the current of 7.5 amps. And just use your calculator when you need to. Okay, and there's our answer. This will be 900 watts for that problem. Okay, so you can see here that thus far we've just had to use the 1 power formula in one of its 3 versions. Okay, so I'm going to move our textbook so we can see the next problems. All right, and I'll tuck this up here. So move over a bit this way too. Okay, let's go on and look at problem 10. A 500-watt electric iron, always the iron, which, I mean, who irons anymore? It's not done a lot, is it? Especially when we're not leaving our houses very much. But anyway, a 500-watt electric iron has a voltage drop of 112 volts. What current to the nearest 100th ampere exists in the iron? So we are given power and voltage. We are finding current. We are given power and voltage. We are finding current. The formula is P divided by E. So we will take 500 and we'll divide it by 112 to determine the number of amperes. So 500 divided by 112, there's the answer. What kind of rounding did they ask for? Nearest 100th. So this is 2 decimal places. So the 6 is the number of interest. Beside it is only a 4, so this remains a 6. So 4.46 will be the number of amperes. Oh, look what I did. It's 550, not 500. Okay, my mistake, obviously. Nobody else could have made that mistake. I'm the only one here. Okay, so let me change that for you guys. It's actually 550 that we're dividing by 112. So let me fix that. Okay, 550 divided by 112. There you go. There's the answer. And rounded to the nearest 100th will be 4.91. Okay, sorry about that. That's actually correct now for problem 10. Okay, let's look at number 12. Number 12 says, a circuit uses 216.2 watts and draws a current of 1.88 amps. Find the resistance. So let's write down what we're given. So we're given a power value. And we're given a current value. So we know that with these values, we could find voltage, okay? But in fact, we are asked to find the resistance. Okay, so how could we proceed? Well, if we begin and find voltage, once we have our voltage determined, we could then use Ohm's law in order to find the resistance. Okay, so I'll show you that first, and then I'll show you something else as well, an alternative. So we could start by using power divided by current to determine the voltage. So the 216.2 is divided by 1.88, and we get 115 volts. Great. Now that we have the voltage, can we find the resistance? We can, using Ohm's law. We know that the resistance will be equal to the voltage divided by the current. So we could take the 115 volts that we just calculated and we can divide it by 1.88. So the 115 is still here on my calculator. If I just divide by 1.88, I will now have the resistance that was required for this problem. And the rounding is to the nearest hundredth. So that would be 61.17 ohms. And then our problem would be complete. Okay, so it's just a two-step problem. First, begin with that power formula, the one highlighted in this unit to get voltage. Then go back and use Ohm's law, which was certainly practiced in the previous unit, unit 37. Okay, but I'd like to show you something else, okay? So certainly that's brilliant. But going back to the original here, we had power and current given and we wanted resistance. There is a formula directly relating only these three quantities. And it goes like this. If power is E times I, but E itself is I times R, that means in this formula where the E is, we could change the E to I times R. So now we get I times R times I for power. And that's the same as power is I squared times R. So this is a formula right here that can be used, which relates only the three things. You see, if you use this formula, then you don't have to calculate the voltage. You can take this formula and we're given P and we're given I, so we can solve it for R simply by dividing, right? So if I wanted to take this formula, power is I squared R, which is a formula you might already be familiar with anyway, but this is where it's derived from. If I wanted to solve this for R, all I would do is divide both sides by I squared. So P divided by I squared is R. And so then I could simply use these values to obtain the resistance. So the resistance is the power, which is 216.2 watts, divided by the square of the current, so 1.88 squared. So let me go ahead and do that for you. 216.2 divided by 1.88 squared equals, and you should not be surprised to see that we'll get the very same result. So this is 61.17 ohms also. Okay, so what I did was I presented two different ways of solving problem 12. In the first way, you calculate voltage first, then resistance. In the second way, you use the formula P equals I squared R, and and the given quantities to get your resistance. And you don't have to calculate the voltage first, but you're welcome to use either of those approaches, obviously, whatever you like better. Okay, we got 2 more questions only to do, 14 and 16. So let's read 16. No, 14. I should probably go in order. Okay, a motor uses 5,595 watts. So that's power. Okay, so that's power in watts. So the question is asking us to find the horsepower load of the motor. So all that means is take this quantity in watts and convert it to horsepower as the unit instead. And they're showing you to just take your power value and divide it by 746. And that's correct because every 1 horsepower is 746 watts. Okay, if you wanted to do it using, the dimensional analysis that you've learned in this course, you could do this, right? You have this. Every 1 horsepower is 746 watts. So if you set it up like this, watts cancels and the unit remaining will be horsepower. So we're basically taking the number, multiplying it by 1 and dividing by 746. Okay, so 5595 divided by 746, that's our answer right there. And interestingly, you get a nice even number, 7.5 horsepower. Okay, so this is a ratio that helps you convert from watts to horsepower. And both are units for power. Okay, our last problem right here, 16. So find the number of watts in the armature of a generator having an internal resistance of 0.3 ohms and a voltage of 6 volts. Okay, so what are we given? We're given resistance and we're given voltage. And the voltage is 6. Okay, and the question is asking us, determine the number of watts. So in other words, find power. So I'm going to do this one 2 ways, just like I did number 12. So what is the first option? The first option is to note, oh, interestingly, if we have E and R, of course we can find current, and that's just Ohm's law. So we can start by doing this. 6 divided by 0.3 is the current in the circuit. Okay, and that's 20 amps. And then once you've determined the current, if you're looking for power, we know that power is just E times I. And so we can take the 6 volts and multiply it by the 20 amps that we just determined. And this will give us 120 watts as our final result. So that's one way you can figure out number 16. It's just a 2-step problem. First Ohm's law, then the power formula. Okay, and number 12, you'll remember, was the opposite. First the power formula, then Ohm's law. Okay, but there's another way we can do this as well. There is a formula directly linking power, resistance, and voltage. There is a formula directly linking these things. So it looks like this. Yes, power is E times I, right? but we don't actually have I here. But we know I, according to Ohm's law, is E divided by R. Okay, so we can take where the I is and change it to an E over R. And what does that give you? That gives you this version of power. So instead of the I, we can put in E over R. And now what do we get? We get, oh, cool. So power is E times E, or E squared over R. So this is a formula for power, again, that you may have used already in your other courses. And it's just derived from these two basic formulas, the power formula and Ohm's law. And you see now the only quantities in this formula were given in the question. So we don't have to start by finding the current. We can substitute directly into this formula. So we're gonna have 6 squared divided by 0.3 will give us the power. And I bet you know what the answer will be. Okay, let's just verify it though. So 6 squared divided by 0.3, and yes, we get the same answer that we got here in number 16 by doing 2 different steps. First, figure out the current, then figure out the power. Okay, so again, for problems 12 and 16, I just wanted to show you where these other versions of the power formula come from. So power is E squared over R, and power is I squared times R. Okay, whoops. Let me move that up and say that again. I wanted to show you where these came from. Power is E squared over R, and power is I squared times R. Okay, but as I've said a few times now, doesn't matter to me which way you solve the problems, either the 2-step way or using the power formula that only involves the given quantities. Okay, thanks so much. Please take the time to try the odd numbered problems in the unit, okay? So this is Unit 38. I'd like you to try all of the odd numbered problems. There really are not that many. It's only this page as well as this page. So try those and check your answers at the back of the textbook. Let me know if you have any questions. Have a great day.